In this video, I want to introduce you to the position function in one dimension. So it's important to note that the position function is a vector function of time. That means it's a function where you input a time, and what you get out of it is a vector. A vector is an object that has both a magnitude and a direction associated with it. What does this vector tell you? Well, this vector gives you a location of something, and that something, the location of it, at the moment we're going to limit ourselves to one dimension. Okay, so let's start with a mathematical representation of such a thing, just as an example. So here I have a function x of t given by 20 minus 10 t, and I'm going to say that my position here is in units of meters. So here's a mathematical representation of a position function in one dimension. And so that's might be fine enough. Let's look at it in a different representation. In fact, let's look at it sort of a tabular representation. We can get ourselves a table that for specific values of time, say 0, 1, 2, 3, we can find specific positions at t is equal to 0. If I put 0 into this function, I get 20. If I put 1 into this function, I get 10. If I put 2 into this function, I get 0, and then 3, I get negative 10. And I was told here that these are in meters. So here I have a tabular representation, gives me the location for specific points in time. Such a thing might be useful if I wanted to create now a graphical, a sort of a schematic representation. Now this mathematical representation, in fact, assumes a couple things that you should be familiar with. It assumes that we're looking in one dimension that I've identified as an x-axis. So an x-axis with some sort of origin and a positive and negative direction. And so if I identify now here, let's see, here's 10, 20, here's negative 10. This function tells me that at t is equal to 0, this function gives me the following vector. It has a magnitude of 20 meters, and it's pointing along the positive x-axis. So there's t is equal to 0. At t is equal to 1, then I have a vector of magnitude 10 pointing in the positive x-axis. At t is equal to 2, I have the 0 vector, no magnitude at all. And at t is equal to 3 seconds, I have a vector whose magnitude is 10, and it's pointing on the negative x-axis. Remember, these are still vectors, but in one dimension. The absolute value of the number gives us a magnitude, while the sign gives us the direction. All right, just to complete our picture, looking at the different representations, let's look at a graphical representation. It's important to get familiar with all of these different types of representations because they become important in looking at and solving problems. So here I have a function, x of t is a function of time, and so if I plot here, here's my position, 0 to negative 10, and time now is on the horizontal axis of 1, 2, 3, and now at 1 it's 20, 2 is 10, 3 is 0, 0, 1, 0 is 20, 1's at 10, 2's at 0, 3 is at negative 10, and so I have a sort of straight line through those 4 points. And so this is now a graphical representation of this mathematical function. Okay, let's do one more example here. And in this case, I'll look at this function, a mathematical representation, y of t is equal to 20t minus 10 t squared. And again, I'm just for unit's sake, I'm going to say t is in seconds, time is in seconds, and y here is a position that's measured in meters. Okay, I'm not going to worry too much about units at this point. So here's now a mathematical representation of my vector function in time in one dimension. Let's do it again. Let's get a tabular representation of some points. Position y of t is a function of time. Here, 0, 1, 2, and 3. So at this point, if I plug in 0 into this function, I get 0. So its location on the y-axis is 0 at t is equal to 1. If I put 1 second into this function, I get y is equal to 10. If I put 2 into this function, that's 40 minus 40, that's 0. And put 3 into that function, I get negative 30, 60 minus 90. So if I were to, again, let's take a schematic representation of what's going on here. Now I'm going to put my y-axis, I can put it any direction I want. I'm going to put my y-axis going up. So here's the negative y going down, and then I can put points on it. Here's 10, 20, 1, 2, 3, down here negative 30, 10, negative 10. Okay, and so what is this function telling me? So it's giving me a vector, and so at t is equal to 0, this vector is 0, it has no magnitude. At t is equal to 1, it's giving me a vector with magnitude 10, and it's pointing in the positive y-axis. At t is equal to 0, it's again giving me a 0 vector, and at t is equal to 3 seconds, it's giving me a vector of magnitude 30 that's pointing in the negative y direction. So again, we have this one-dimensional vector function of time that gives us a vector for each time that has a magnitude and a direction. In one dimension, the direction is given by the sign. If we were to look at a graphical representation of this one, so now again I've got y as a function of time here, 10, negative 10, negative 30. Now here at t is equal to 0, I have the 0 vector. At t is equal to 1, it's at 10. At t is equal to 2, it's at 0 again. And t is equal to 3, it's at negative 30. So what sort of thing does this represent? Well, we know this is a quadratic equation, so the graph that this represents is a parabola. I can sketch that parabola, and it looks something like this. Do I know exactly that the maximum is at t is equal to 1 second? Well, maybe not just by this graph, but if I know some calculus, I know how to calculate the maximum of a function. I can differentiate this function. Let's call this function back here. So I can differentiate this function, dy dt is equal to then 20 minus 20t. So that's the derivative of that function, and if I set that equal to 0, I can find the time at which this function is either maximized or minimized, and that gives me t is equal to 1. And so that convinces me that that the maximum of my parabola here is at t is equal to 1. Okay, well that helps me sketch this, but the main point here is just to introduce the one-dimensional vector function of time in all of its different representations, reminding ourselves that it's still a vector where the direction is given by the sign of the number.